Hello everyone, it is August 2nd, 2023, and this is the bi-weekly libhal meeting. Now we didn't meet last week, I moved it to this week to kind of get more things done. So the TLDR highlights and the agenda for today. So the JFrog sponsorship is still in progress. Right now, I actually emailed them and then called them up and scheduled a meeting. We met day of, and they said that they're currently still looking into it. They're still waiting for it to get through approval. Hopefully, it gets through approval. I don't see why we wouldn't. So that's in progress. Hopefully, that happens by the end of the week. I'll post on announcements if that ends up happening. And then also merge a change that updates the libhal documentation to have the JFrog logo there as like a part of our sponsorship list. Next up, releases trigger package publish and unpublish. So whenever you publish or unpublish a release, so the publishing part, if you publish a release on GitHub, that will get CI to fire off and push a new package out. Normally, when you do all the CI steps, it actually does all the steps prior to actually uploading the new package. We don't need to upload packages for normal CI. We only want to do it when the new release comes out. So this is how we, ensure that we don't double upload, because that might cause a thing called a revision, which isn't the best thing. Revisions are where you keep the same version, but you update the code anyway, which they advocate against, but they do support because there are some weird edge cases where Conan or some users needed to support that particular behavior. I think it's useful when you accidentally released the wrong version for one version, so you put out a revision of that version that's correct, and people just have to point to the new revision, but yeah, it's a little complicated. And you can't take the old one down. Next up, we have add soft namespace for libhal soft library. So a lot of things that are in the libhal soft library are in the HAL namespace, and that namespace I want to leave for the interfaces and utilities that utilize the interfaces, or just overall utilities in general. I want package-specific things to stay in their packages. So utilities should and ought to be on the HAL namespace. I was reading through the C++ core guidelines, and they have a little statement about how you should keep like things in the same namespace. So all objects that you have for a namespace, all the utility functions for that namespace, or all the utility functions for those interfaces and objects should be in that same namespace, so they're near each other. So we're keeping that. But libhal soft is its own thing. It doesn't and shouldn't really be in the HAL namespace. So there's going to be a breaking change. It's just going to add HAL soft in the thing that you need. So if you want to create an RC servo, it needs to go HAL soft RC servo in order to create the object. That's pretty much the first three. The next ones, which we actually have slides for, are the one API doc to rule them all. I think people are really going to like this. Libhal FreeRTOS is in fact working, and libhal macromod is a new design, a new library that I'm really excited to talk about, because I think it really shows the great power of libhal and really hits something that I've been wanting. It's one of the reasons why I made libhal in the first place, is something like this type of library. So let's continue on. The one API doc to rule them all. I'm going to bring up Madeline specifically because she's the one who brought up this issue. So Madeline brought up the difficulty when developing a driver for libhal, that she had to switch between multiple API docs to see what she needed. Either libhal's API docs, or LPC40s, or STM31, or utils, so on and so forth. This quickly became an annoyance for her and reduced her velocity. She always had to switch between and not really know, and may not always know where everything is. She proposed a single API doc for everything, and that's what we have done. You can now find all the APIs here. Libraries that do not appear on these docs are libhal packages that bring in third-party libraries, such as FreeRTOS. There's no reason for us to re-replicate all the documentation. You can go to the FreeRTOS website to find all the documentation. So I'm going to give you a little tour of this. So here we have the new documentation. So you can also see a couple of things that are new. So one is that now we have a navigation bar here. It looks a little better. The left-hand side navigation bar was getting a little cluttered. So everything here is most of the same. I think I've gone through all the different changes that have happened here. If you haven't read through the user guide, I highly recommend that you do that. There's a lot of good information here. And also explain quite a few different things, what concrete drivers are, multi-interface support, adapter functions, and all that. Yeah, so you learn a lot about libhal by going through all this. Same thing with contributor notes. If you're going to be working on and being a contributor, it's best that you look through everything up into the point where you hear architectural design decisions. You can definitely read these. They're just long, and there's a lot of them, and I'm going to be adding more and more to them as time goes on. Project information, same as it was before. And then finally, we have APIs. So here you can actually find the APIs for basically everything. I'm going to refresh this real quick. Okay, so that's still there. I need to fix that. I will fix that pretty soon, though. Okay, so you can find all the different sub namespaces in the HAL namespace, Cortex M, error, which I'm actually probably going to, well, I might just keep it as it is, but I was considering flattening this out. ESP 266, literals, that needs to be in its own namespace. LBC40, make is being removed. Mock, RMD, soft, STM31, and stream. This will be removed, and so will bit. We're going to flatten those out. Now, we also have all the different classes that we have available, and also all the different types and functions that come with this as well. So this is basically all the utilities. So all the functions are basically going to be utilities, and maybe also some utility classes that exist above. And then also a set of interfaces and a set of attributes, such as these concepts here. Although I don't think this is rendering this correctly, which I think is just a problem with Doxygen not supporting C++20 concepts. But yeah, so that's this namespace. If we look down here, we can go to libhal LPC40, and you can see that we have an ADC, a CAN, a clock, an I2C, an input pin, an interrupt pin, and so on and so forth. So you can see all the different types they have here. You can see the interrupt request enumeration, as well as all the peripheral IDs and stuff like that. So yeah, all this stuff is here. You can also search it. So let's say I want to go to STM32F1. Let's say I'm looking for output pin. Yeah, output pin right here. So we can go here, and now we have output pin. So we can go, you can search, you can use the search bar here to search for anything that's on the website, which means all the APIs are here. After that, we also have a hierarchy if you want to see what things include what. So it's really useful to see the set of accelerometers we have and ADCs that we have and that kind of thing. And then files, if you want to just kind of browse through all the different files that are available, you can do that to kind of see where everything's located. So that may help with finding things like certain types of objects, classes, interfaces, that kind of thing. And click here and you can see all the things that are incorporated inside of that file. So that is the new documentation. Yeah, there was a back and forth with me on whether or not having everything in one place is going to be a little bit too overwhelming. I think the namespaces ends up helping out a lot. Our idea of each package basically gets its own namespace, provided it's not a third-party package, will actually help us out a lot. Utilities will obviously just stay in the normal, in the HAL namespace, but everything else will have its own place. So it'll be very easy to find a particular library by just looking up its package name / whatever thing you need. And I think this will just make it easier for users and developers to go about and find the things that they need to be successful and be useful. So I think actually having all the documentation in one place, and I know it's going to blow up because if we end up having literally hundreds of libraries at some point, which I hope we do, and we probably will if we keep this up, I think that simply having a centralized place to find everything is going to be highly beneficial for the project. And then things that are outside of libhal itself, they'll be in their own place. So yeah, that's the one API doc to rule them all. libhal FreeRTOS is working. I was considering actually making a video. I should have made a video to demonstrate this, but I don't have one at the moment. But currently, we're still investigating the preliminaries into FreeRTOS and libhal. There are some complexities that are here, but I do want to explain a little bit about how I would have got about fixing this, because honestly, it should have just worked. I've ported over FreeRTOS in the past before, and it usually just works. It's not too hard to get working. But I had made some particular decisions with the libhal ARM Cortex implementation for interrupts that messed me up. Basically, right here we have an interrupt vectors table. And at the bottom, well, let's look a little one above the bottom. We have reset. So this is the reset handler. So the address here should be the first function gets called when the system boots up. Non-maskable interrupt, hard fault, all the different faults that you can have, like memory management fault and usage fault. Then we have svcall, software interrupt call. pend system, tick, and a whole bunch of other interrupts that are platform specific. Now, when we build, we actually don't do what a lot of other embedded systems do, which is put the entire interrupt vector table in Flash, where this is. We actually use the CRT0 assembly file. It's all to say that that's a startup file that ARM gives you, and I like it because it actually provides you the initial stack pointer as well as the reset handler, and that's it. That's your entire IVT. This is beneficial because it doesn't take up as much flash, but because it doesn't take up any flash, not really wasting space by moving this thing over RAM. Now, I know RAM is less than how much you have in flash almost always, but the ability to relocate the interrupt vector table from flash memory into RAM is critical to be able to swap out entries at runtime. So previously, what we did was we created an array in RAM, and then we relocated the interrupt vector table to it. There's a register in the ARM Cortex CPU that you can change, that you can set in order to set where the location of the interrupt vector table is. What we did was just set all the entries to a no-op function. The problem is that FreeRTOS actually uses the initial stack pointer value to move its stack pointer back up to the top, basically reclaiming back all the memory that was used to start it. The problem was, because I set everything to no-op, it would try to set the IVT location to be, or the stack position in RAM, which is supposed to be in RAM, to a flash position, and that causes a seg fault. The moment you try to write to the stack pointer, you would immediately fault. So that's why we're having faulting issues. The change now is just simply to copy the previous interrupt vector table before you move on to the next one. Now, there are a couple of unsolved problems with FreeRTOS. It's not like we're done. It may seem like, okay, you just need the binaries. You need to build the project for ARM Cortex M4. You need to bring in the port file for M4 and M3 and M4F and all that stuff. Great, it should be good. It should be easy actually. But there's this pesky little thing called the FreeRTOS config H file, which is required for the whole thing to build. Now, due to the flexibility of FreeRTOS, basically, actually, let me show you guys what this thing is before I go into this next section. So you're able to customize the compiler. As I say here, FreeRTOS is customized using the configuration file. Every FreeRTOS application must have a FreeRTOS config file, and it tailors the RTOS kernel to the application being built. It is therefore unique for every single application that gets built. And there are a lot of flags here. We have use preemption, so you can make it cooperative or not. There is use port optimized stack selection. You can use tickless idle, and you have to put in the CPU clock speed, how fast things should actually be operating, max number of priorities, because if you have more priorities, I believe it increases the amount of RAM that's needed. Minimum stack size for like your idle thread and that kind of stuff. A whole bunch of different things that you can add or remove. Looks like this one's deprecated. Now, there are a couple of these that we can just eliminate off the bat. Like, for example, these include VTask priority set and delete and all that. They actually say that these are optional and most linkers will remove unused functions anyway. So yeah, we will set all these to 1, give you full capability for all these things and not, and let the linker handle it for you. Some of the MPU stuff here, I gotta look a little bit into. I have to look into more to understand it a bit more. Config assert, kind of ignore that for the most part. This part is a bit funky. We might have to just set this up ourselves. Yeah, I think there's a default for like ARM Cortex in general, M Cortex devices. So that might be pretty simple, and we might have to do something special for each situation. And yeah, so this is basically a whole bunch of configurations that you can set up and use. Now, the thing that I really dislike is stuff like this: total heap size, and clock speed, even system tick clock, but tick rate's fine. The reason why I dislike these is because you have to define what your clock rate's going to be at compile time. And although you can do this for a single platform, pretty easy, not a big deal. But let's say you wanted to write an application that can work on any platform. What do you do in that case? And this is kind of where the rub comes up. So I'm going to go back and I'm going to kind of talk about what these other issues are. But before I go into the next steps, because all of these different there's so many different ways you can customize this. The package will actually be labeled as build missing. The only other package that we have in libhal that's currently labeled as build missing is the ARM GNU toolchain. That particular package is set to build missing because of the fact that there's never going to be a pre-built for that package. That would mean we'd have to cache the package binaries, and we don't want to do that. So we always download the binaries for you. This one has to be the same way. We're going to download the source code and we're going to build the RTOS to your specifications, because there's no way that we're going to be able to pre-build every single possible option for the for the FreeRTOS config H file. But I think that this should be relatively simple. It shouldn't be too difficult. And because of this, I realized that rather than having all of us install CMake globally on our machines, you can actually just install CMake as part of a tool in Conan. So in the future, not too far out future, it's likely that the only step you'll need to get to be ready to use libhal, the only prerequisite is to have Python installed and to then do pip install Conan. After that, the rest is handled for you, which I think is great. Yeah, so how do we handle this? We automatically generate the config file given the Conan package options. So whenever you depend on a library or on a package, you can specify a set of options about how you want the thing to perform, how you want it to be built. We can leverage that in order to actually build that FreeRTOS file in the package, place it into the source location, use it for building the application, and then use that for yourselves. But one of the biggest items here that's hard to figure out is how do we handle FreeRTOS's configs CPU frequency. Now, if that was just for reporting stuff, maybe we could maybe we could do something about that. The current issue is that it does use that information for benchmarking and a whole bunch of other things throughout the code. So you can't, if it was a variable, then we can maybe set it at runtime and then execute the kernel. But because it's something that's baked in at compile time, it's kind of an annoyance. And also same thing with the systic timer, which we also need to set the value for that as well. So I don't have a solution for that yet. I'm still considering that. If anyone has an idea of how we could go about handling this, that would be great. At one point I considered, I could just set it to some arbitrary, let's say 1 gigahertz, and have the sleep function just be, have some conversion for it. The only problem with that is that we'd still be running the system tick at a multiple of whatever our actual clock rate is, meaning that we spend more time transitioning through threads than we actually do doing any real work. So that's a problem. I'm still workshopping this, and if anyone else has any input on this, please bring it up. And finally, we have libhal micromod. There's a typo here, should be an O there. First, I think a lot of people here, I think I've spoken about micromod before, but I just want to make sure we do a quick recap. Micromod is SparkFun's general standard for MCUs. Just like how we have a standard socket for RAM, we have a standard socket for certain types of processors. This gives us a standard socket for microcontrollers. Now, the cool thing about this is that it gives enough space for a whole bunch of different GPIO, some differential ADC, SPI, I2C, PWM, USB as a host, CAN, some debug pins, UART, I2C again with the interrupt pin, another UART, PWM, audio, more GPIO, SDIO, and another SPI. This is pretty much what you need for most applications. It really does give you everything you need. Now, obviously, you may want more I2Cs for reasons, you may need more SPIs for reasons, but I do believe that with the micromod system, and using I/O expanders and using devices that work over CAN and using I2C with I2C buses and that kind of stuff, you can basically scale this thing up pretty large to a pretty vastly. So I love the micromod system because it really does standardize all the different pinouts here and ensures, or at least the idea is that everyone who makes a micromod board will follow all of these things and let me check something real quick. Yeah, we'll follow follow these protocols to the best that they can with that chip that they're using, and you'll be able to have a consistent set of features for that specific chip. At this point, it doesn't really matter which chip it matters what chips you use, but it doesn't matter about how you have to plug it in. That's figured out for you. So now you can just choose what thing's going to perform well for you, what things hits your price requirement, what things have additional features like Wi-Fi and or Bluetooth that fit your needs. So that's the Micromod system. Now, libhal Micromod eliminates the need for a separate platform file for platforms that utilize the Micromod system. For example, there's the SAMD 21 or 51, I forget which one it is. There's a Micromod for it. With this, you would not need to create a SAMD 51 platform file. You wouldn't have to figure out how to map all the different GPIOs or ADCs or whatever else you're using to a hardware map. You would not need to do that anymore. The beauty of Micromod is that each peripheral is mapped to a specific pin in the Micromod. Each carrier board that uses Micromod will always use the same pins for CAN high, CAN low, and UART, etc. The exact peripherals and pins used for each connection on the Micromod for the platform is well defined. That's how you eventually have to do it in order to make an API mapping or just to use the Micromod in the first place. Libhal Micromod maps target platform peripherals to a Micromod API front end. Let me show you what that looks like. So here we have HAL Micromod v1. We have all these different interfaces that we have taken in. And we have initialized platform, we have reset, we have clock, we have console, we have an LED. We have the analog pins 0 and 1. We have the battery analog signal, a couple of DACs, a couple of PWMs, I2C and the interrupt pin associated with it, another I2C. Same thing with SPI, same thing with UART, CAN, and then the GPIOs such as output, input, and interrupt pin. Now, I'll show you a demo. I haven't run this demo in a while, and I'm not sure if running this thing will actually work. But here, the beautiful thing is that we don't need to really worry about having a platform file for this thing. If we call initialize processor, so long as we set our profile to LPC 7048, the package will determine, hey, does this thing actually exist do we have a pre-built package for this particular platform? If yes, then it will fetch that pre-built binary for that particular platform. So for example, here, you can see it doing that work right here. Well, basically it requires the libhal LPC, and then the CMake file here will do the work of finding that particular source file and bringing it in. And if you look at the source file here, it's a bit long, but we have the parts for initialize processor, which is initialize data section, initialize the floating point unit, initialize the interrupt vector table, set the clock speed to maximum, and then return back success. There's nothing that goes wrong here, but there might be a processor initialize that actually, is a little more complicated and ends up having a failure mode. We have a reset function. We have our clock. We have a console, which I'll talk about a little later. LED, and so on and so forth. So, yeah, so all these are mapped out so that you can very easily just grab them. So here in our main, we just initialize the platform, check to make sure that worked. Then we run the application. In the application, we just include libhal Micromod, and we can start using things. So we can grab a clock, we can grab a console, we can grab an LED, and we can print out some messages, we can control the LED, and so on and so forth. To me, this, honestly, when I got this to actually work, or put everything together here, it made me feel like what I believed Arduino was going to be for me when I first started using it. It felt like, oh, this is a way to always ensure that our code works for whatever processor that you need. It feels like the promises that Arduino made, but in this case, we actually kept. All the APIs are consistent, or they should stay consistent, or actually, for the most part, they have to be consistent across each other. For different versions, things might change, but you'll know that if you're using a certain version, that the APIs will all ought to act the same, so long as the drivers beneath them work as intended. So you can write your code once and deploy anywhere. This application, as we add more and more backends, to the Micromod front end that we have will mean that we just simply add this application to the list of things that it can support, rather than having to write for each library and each demo a separate platform file that they're not even redundant. They're all unique, but each one of them ends up being so unique to the point where like there's no code reuse. But you end up having to write the same thing over and over again. Like, oh, I need GPIO 00, I need GPIO 00, I need GPIO 00, but it means something different each time. With this, you can just write your application using the Micromod system, Micromod APIs, and you just set your profile to the chip that you want, and you're done. It just builds that chip. You can load it up, and it works. I was going to do an experiment with STM, but I know it'll work just fine. Just takes some work to get this whole file set up. So that is honestly the one of my favorite things about working on libhal, because I was pretty much building up to this entire time. I've been wanting to have something where you build your thing once and deploy anywhere, and I feel like we're getting there. And this doesn't just stop at Micromod. No. Technically, we can support Arduino in the future. Although Arduino's a bit difficult because Arduino, although like a lot of the pins have a certain specific pinout they're supposed to have, a lot of devices will mux a lot of different things, and then people will want to utilize all that stuff. The Arduino footprint's kind of limited, so that's the thing to keep in mind. And there's certain things that we might not be able to always uphold. Like for example, for the Uno, some of the analog pins act as I2C pins, which not all devices will mux I2C with analog. So that's Arduino. That's the issues with Arduino. But Feather, we might be able to support Feather. We might be able to support, I think Seed may have their own standard. So that's another thing we may have to support. And I think that pretty much is what we're capable of doing. We're able to support pretty much any standard that gets brought up. We make another libhal for it, and then we can make sure and ensure that our projects work across each other. Can work. You can deploy. You can use it and then play anywhere. So that's libhal Micromod. Now there are a couple of problems with libhal Micromod. One of them is the problem of setting system clock. I have not a really good idea about how to solve this problem. And the main idea is that like every single device that you work with will have a different clock associated with it. So how do you choose one? How do you know which one to choose? So for example, you can't just say like 10 megahertz, because what if your chip doesn't go that fast? Or you could say 100 megahertz, but the LPC I know for a fact can only go up to, actually, LPC can go up to 120. Let's say we go like 250. Well, LPC can't do that. STM darn sure can't do that. Even if you try using the overclock method, yeah, no, they just can't support it. So what happens? Do we just fail? But then that means this particular application only works for things that can go a certain speed? Maybe. But maybe I could see an application where a user needs a certain clock rate to ensure that a certain process can work appropriately. But I can also see a user just putting down a number and just thinking it's fine. But that doesn't make a lot of sense. And I think that may end up just resulting in some really weird behavior with the program. Now, we could use percentages. Some value that's greater than 0 and less than or equal to 1, whereas 1.0 is the maximum speed. I don't know how reasonable that is. And if the clock speed is too slow for certain peripherals, like for example, if you try to use UART and you want to use 1 megabaud, you actually need at least 16 megahertz of a clock going to that UART peripheral, so it can do a multiple sample of that particular signal. Now, if you set it to some particular percentage, at least you know that it'll tell you, hey, this won't work. It'll throw an exception at runtime, or throw an error at runtime. So at least you can go, okay, that particular tuned value doesn't work for these set of devices, so maybe you have to bump it up a little bit higher. But you're just trying to find the minimum value that'll work for all the things that you want to support, and also reduce the amount of power consumption overall. Another option is just to simply set the speed to the maximum, like I'm doing currently. And you may think, okay, well, isn't that bad if you want to reduce the power consumption? Well, maybe what really needs to happen is you operate quickly and then you go to sleep whenever there's no work to be done. FreeRTOS will help with that a lot, so well as any other RTOS, where you do some work, you have nothing else to do, you're basically blocked, so then you go to sleep. So you spend most of your time sleeping and quickly getting up to do work. So it's another option. I'm not sure what is the best option. So if people have an idea, please message me in discussions or in libhal ideas, just so we can talk about it. Also, I'm pretty certain I'm gonna do this, but for console, it's currently serial. But I think what makes more sense is to do something more like puts and gets s. Gets s stands for get size from the C standard library, which basically just boils down to be console write and console read. So we want a way to send a message to console. We also want a way to log to console. We also want a way to read data out of console if that is something that our application wants to do. And rather than using serial as the interface for that, we can just have a function that takes a set of bytes and also reads from a set of bytes into a buffer. That way, the underlying implementation does not need to bend its way. How should I put this? It doesn't have to contort itself to fit the libhal serial. I think any library that can talk to a console would basically could work, but we could also not have that kind of complexity. For example, you can have some global and or static UART that acts as our serial, and then do console write and read with that, or have it be static and then have it initialized for the first time when you call the console write or read functions. Another option or another idea that can happen from this is that USB implementation. So rather than having UART or serial be the backend, it's actually a USB. So this frees us up to do that and also explore other potential devices or systems that can be used for logging. I mean, shoot, there's no reason why you couldn't log through Wi-Fi. It might be a UART that goes over to Wi-Fi, but you might need to do that. So that could be another way that console works. And I was also considering even having like a couple utility functions that basically do print and that kind of stuff, akin to what you'd expect. So like printf may overload to actually writing stuff to console write and that kind of thing. Who knows? Just some thoughts. But for now, the biggest two problems here, or at least the biggest problem here, is actually how do you set the clock rate? So that goes double duty. FreeRTOS has this problem, and so does libhal macromod. And do you want to go over a couple of solutions that we have found for things? At one point, I considered how do you choose which backend, which version of the platform library to use. And it really comes down to this. There is a selected one in the Conan file.py that is just going to be used, and it gets upgraded every so often when people want it to be upgraded. But if you want to skip waiting for it to be upgraded, you can actually just set the version in the options for Micromod. There's a way to do that in Conan. You can just set a version string, and then we'll use that version string for you. Now, if that version string doesn't exist, then we throw a compile time error, or a build error. If that thing that does exist but is not compatible, then you'll see a build error, most likely. We may even potentially do some work to check the major numbers to see if they're compatible. Because if the major numbers don't work, we can just give you an error telling you this particular version of Micromod does not have a map for this other newer version of this library. So that might be a thing. And the Micromod package number will pretty much just increment with every single update that comes. That isn't something that people shouldn't have to worry about too much. Just they just have to figure out what package is associated with which package version for the thing they're trying to use associated with that Micromod version. And the major number will increment whenever the public API breaks. And then also for revisions of different Micromod boards, I do plan to actually have profiles for those particular types. So for example, we're already on V5 for the LPC 4078, and I might make a V6 because I want to have the PWM come from two different sources, one from the motor PWM and one from the PWM peripheral, because then we could actually set the frequencies different from each other, which would be fantastic. And I think STM32.103 is actually pretty maxed out. I don't think there's much to optimize there. So it might not be a version 2, but just something to consider. And yeah, that's pretty much the libhal meeting.